All right, this video is for Calculus 6.1 and it is on slope fields. So slope fields is a visual that you will start seeing for graphs of a general solution. Remember, general solutions have a plus c, and if that c was filled in with a number, that would be your y-intercept. So being that we don't know our y-intercept, we have many possible graphs, which is why the full graph is filled with tallies, which I'll show you in a minute. A side note for AP students, this is the only graphing you'll be expected to draw by hand on the actual AP test, okay? So there's two things they could give you for this question. They could give you the original function or they can give you the derivative. If the original function is given, you're going to analyze those tallies as an entire graph and try and see what image matches up with the equation. If they give you the derivative, remember derivative means slope, you are going to be able to analyze each ordered pair and then analyze whether the tally represents a positive slope, negative slope, and so forth. So as a quick reminder, this is something a little silly from Algebra 2 that I used to teach Mr. Slopeface. The positive slope goes increasing from left to right. Negative slope, decreasing from left to right. A zero slope is a horizontal line. An undefined slope is a vertical line. And then lastly, if you get an indeterminate, which was like 0 over 0, then you won't see a tally on that spot. So if we look at this visual here, they're giving me the derivative. So because they're giving me the derivative, I'm going to analyze each tally according to the ordered pair. So you want to start making some generalizations. Just by looking at this, I know that anytime x and y are the same number, then my derivative, my slope, should be 0, which means I should see a horizontal line, which is why on 0, 0, 1, 1, 2, 2, -1, -1, and so on, I have a horizontal line for a 0 slope, okay? Now, you can also see over here on this left side that I start getting negative x's, okay? When my x is negative minus a positive y, I'm going to have a negative number, which means a negative slope. Over here on this side, when I have a positive x and a negative y, positive x minus a negative y will end up giving me a positive number, therefore a positive slope, which is why we drew the positive tallies. So we're looking at this question, and it says to sketch a slope field for the differential equation. Differential equation just means that they're giving you the slope already, which matches up with what they wrote next, okay? Y prime. And the equation for the slope, for the derivative, is negative y over x. So I want you to be able to do this as quick as possible. Remember, in the AP, you're timed. So generalizations. I know that when x and y are the same number, okay? When x equals y, my slope is going to be 1, but then there's a negative here, so this is going to be a negative slope. Next, I know that anytime my denominator, x, is 0, I'm going to have a vertical tally. Anytime my numerator is 0, now my slope is 0, so I'm going to have a horizontal tally. If both numerator and denominator are 0, then there should be nothing because 0 over 0 is an indeterminate. Okay? And then lastly, I analyze the quadrants. Okay? So in quadrant 1, I have positive, positive, which when you divide those, you get positive. But remember, we have to multiply by this negative here. So positive times negative is negative. In quadrant 2, I have negative then positive, which when I divide those, I get negative. But that fraction, which is negative times a negative, gives me positive. Quadrant 3 are both negative, which when you divide, you get positive. But there's that extra negative here. And then quadrant 4 is positive, negative, which when you divide gives negative, but with this other negative gives you positive. So we're not going to draw anything when x and y are the same. When y's are 0, okay, y is 0 means I'm on the x-axis. I'm going to draw horizontal lines. Okay? When x is 0, meaning I am on the y-axis, I'm going to draw vertical lines. Okay? In quadrant 1, I know they're all going to be negative. Quadrant 2, they are going to be positive. Quadrant 3, all negative. And quadrant 4, all positive. Okay, so instead of literally plugging in every ordered pair, your generalization helps you go faster. Now remember that once these slopes start to have horizontal and vertical shifts, your generalization has to move along with that. Okay? All right, so I encourage you to take a moment, pause this video, and try these on your own. But let's take a look at them. For 7 through 10, they're giving us the slopes. Okay? If they give us the slopes, that means I'm analyzing the tallies. So for sine, that might be a little crazy to look at each tally. I do know that the antiderivative of sine is negative cosine. So if my y function is negative cosine, then I should be looking for a full image of negative cosine, which leads me to C. On 8, a generalization I can make is that when x and y are the same number, the tally should be horizontal, which lead me right here to D. 9, a generalization I can make is that when y is 2, the slope will be 0. So you can see here on A at 2, all of my tallies are horizontal. And on 10, I can analyze that when x is 0, I should have horizontal tallies. When x is positive, they're positive tallies, and negative is negative tallies. Okay? You could also take a step further and say that antiderivative would be half x squared, and an x squared graph would be parabolic. Okay? Let's take a moment and look at these. I'm going to have my class help me answer these. Okay? So don't feel like you have to go in order. Okay? Which one did you feel like was the easiest to answer? The circle? Okay, what generalization were you able to make? Beautiful. The origin is indeterminate, which means 0 over 0, which means I need a fraction, which leads me to 13. There was no line. Okay? Next one. Which one did you want to pick next? You thought 11 was easy? What was the generalization you came up with? When x is 2, that would give you a 1 minus 1. It should be 0. And which one did that lead you to? B. You see how on x equals 2 I have the horizontal lines? Awesome. The antiderivative would have been a squared, which is why I see parabolas. Talk to me about 12. Good. When y is positive, it's a positive slope. And when y is negative, it's a negative slope. And that led you to? C. Right? Also when y is 0. Good. All right. And then the last one, 14. Talk to me. What generalization can you make? So when you can think, right, based off of signs. So when x and y are both positive, this will be positive. When x and y are both negative, this will give you negative. Okay? And that should have led you over here. You could also see that when they're opposite signs in the same number, then I have horizontal tallies like on -1 comma +1. And same thing vice versa down here in quadrant 4. Okay? Let's look over to this side. Number 15, notice that they are giving me the actual y function. They're not giving me the derivative. So I know x squared is parabolic. All right? E to the x is growth in the top half. E to the negative x just flips that sideways. Cosine graph, and then ln. And then you can tell that they're only giving me the first quadrant here. So which one does this match with the first quadrant? ln of x, which is letter E. Okay, these should be your time savers on the AP test. And then this last one. I know sine and cosine are curves. Okay. I do not see curves there. I know x squared will have going decreasing on the left and increasing on the right. X cubed is always increasing. And ln of x increases only on the right side. So which image does this match up? Good, an x cubed graph. All right.